Okay, example 2-2 is about a horizontal rectangular channel with the bottom width of 3 meters, which has a depth of 1.45 meters. The question asks us to use energy equation to calculate the alternate depth for a total discharge of Q equal to 2.6 cubic meter per second. So we have a rectangular channel. So the width is 3 meters. The water level in the channel is 1.45 meter, and the discharge Q is equal to 2.6 cubic meter per second. So we know from depth discharge relationship that for any specific energy level, we have two alternate depths. So this is the depth discharge energy. And if I have energy of E, let's say E1, and then if I draw the solution of EY curve for a specific discharge, Q, then that specific energy gives me two solutions. One is subcritical solution, and then the other is supercritical solution. So Y1 and Y2. And Y1 and Y2 are called alternate depths because they have the same energy. So what I need to do is to calculate the specific energy. So E1 is equal to Y1 plus V1 squared divided by 2G. And I need to know the velocity from the continuity equation. I can calculate V1 is equal to Q divided by BY1. So 2.6 is divided by 3 times 1.45. And it gives me a velocity of 0.598 meter per second. Okay, now I replace the velocity into the energy equation to calculate the specific energy. So E1 is equal to 1.45 plus 0.598 to the power of 2 divided by 2 times 9.81. And it gives me an energy level of 1.468 meter. Okay, so the energy is the same. Now I can develop the energy equation E2, or again E1 is equal to 1.468, which is equal to Y2 plus V2 squared divided by 2G. Okay, so I need to search for Y2 that gives me the same energy level, and that's how I can find for the alternate depth. Now, because I have two unknowns, Y2 and V2, I can use the continuity equation. So Q is equal to BY2 V2, and then V2 is equal to Q divided by BY2. And then I can replace the expression for V2 into the energy equation. So there is going to be 1.468 is equal to Y2 plus Q squared divided by 2g b y2 square. Okay, now I can replace the total value of discharge. So I have 1.468 is equal to y2 plus 2.6, that's the value of discharge, to the power of 2 divided by 2 times 9.81 times 3y2 square. Now you see that we have one equation, one unknown, and then we can solve for y2. So what you can do is you can multiply both sides by y2 and then convert that into a cubic equation and solve. So I'm going to multiply the left-hand side by y2 square and the right-hand side by y2 square to just remove the y2 square from the denominator. And then you end up having a cubic equation. And then you can solve for y2. And this way you are going to get a 3 answer. So one is the subcritical answer, which we already have, 1.45. One is negative, and the other one is positive, so with a very low value. So when you solve the cubic equation, you will get y2 is equal to 0.172 meter. So that would be the supercritical answer of the example we have, or the alternate depth for this example.